Share. There we go. Okay. I'll grab my notebook up here. So the volume formulas for prisms are, we actually already started last week. We did the cylinder volume, which I consider a prism also, right? It just has a special name because it's got the circular base. So these two shapes actually start out with the same formula. I want you to write it kind of to the side so we can make it more specific. Volume equals the big B times height, which remember stands for area of the base. So if I want the area of this base, well, that's a rectangle, or I could even possibly get a square in this section. But either way, my real volume formula specific to this shape would be base times height times height. And it sounds funny. I totally get that. I'm gonna color coordinate here to show you what I really mean, just in case. So I'm gonna use the first problem only. I would say the base and the height of just the quote base of the prism, right? I'm only looking at that bottom part. And then this height represents the height of the actual prism. It's kind of funky. Lots of the word base, lots of the word height, but they're specific to specific pieces, I guess, of this shape. Okay. All right, so let's look through some of these here. So let's start with that one I've already color coded here. We're going to show our work underneath. That's kind of what I thought would be best, and we'll write our final answer up here. So volume equals base times height times height. Or in this case, 6 by 3 by 8. I truly feel like rectangular prisms are very nice when it comes to the volume formula, because you're essentially just multiplying all of the 3 dimensions, right? The length, the width, the height, you're multiplying all of it. If you see, if these base and height are switched for you, just because that's what your eye goes to, that's okay. It's multiplication, it's all commutative, so that doesn't matter either, okay? And with our tool, 6 times 3 times 8. Times 3 times 8. And Roy, what'd you get? Perfect. Yes. It is feet cubed, yes. Because again, I think I did that last week where I grabbed that piece of paper and showed it was like inch times inch times inch, right? This would technically be 6 feet times 3 feet times 8 feet to get us feet cubed. Good question. Everybody okay there? All right, let's do a couple more. Like I said, these are pretty nice once you get going. I really, in my mind, I wish I would have taught volume before surface area, because those are the intense formulas that I think would have been a little bit nicer for our brains. But all right, so let's go base times height times height. And I'm going to go ahead and label again. I like the colors, especially for my kiddos at home that don't get to ask questions. So this is kind of a cool one. Like, some of you might refer to the base of this rectangular prism as the 5 and the 10. Some of you might think of it as these two on the side. And again, it truly doesn't matter. I'm going to go ahead and do this one as my base and height, my first rectangle. And then my height of the prism, which remember, all that really means is the distance that separates them from each other, right? I have that 5 by 10 and another one in the back, separated by the 2 inches in between. Okay. Ten times 5 times 2. Now again, if you set this problem up differently, you are not going to erase. That just means your brain saw it a slightly different way in a different perspective, and that's okay. And we don't even need a calculator for that one. 10 times 5 times 2. There we go. 100 inches cubed. Go ahead and take the last one on your own. I'm gonna stop recording this one and I'll jump back in with the triangular prism so we can have some time to chat if we need it.